Today in graphic communication we're going to look at interpenetration, or as it's sometimes known, intersection. So what this drawing topic is about is that we have two cylinders, one smaller cylinder slotting in to this larger cylinder, and we have to finish off these drawings so that when we are finished we have two cylindrical objects that join together and we can see exactly how they slot together. Okay, so the objective of the exercise is to firstly draw the completed plan and elevation, then to draw an asymmetric half of surface development of the small cylinder, that's this part here, and then finally to draw a development of the large cylinder, which is this part here. Okay, so let's get to it. The first aspect of this is that we need to do a little bit of construction work over here for this small cylinder. So I'm just going to extend this centre line out a little, and I'm just going to draw a centre point here. Now, the diameter, or sorry, the radius of this small cylinder, I'm going to lift it from here, and I'm simply going to draw a circle here. This is merely for construction work. Okay, that circle I'm going to split into 30-60 segments, like so. And as I said before, this is just for construction work. It's just to get an idea where the lines cut through the circumference of the circle. Okay. The next thing that we want to do here is I'm going to draw, again, construction work here. I'm going to draw a semicircle just on this part of the pipe here, and I'm also going to divide that up into 30-degree segments with the 30-60 set square. Just so that I can get these points where it cuts through, the lines cut through the circumference of the circle once again. Okay, now what I want to do is I want to, in the direction that the pipe is flowing here, I want to take these points down. So in other words, at 30 degrees, I just want to bring these points, and we're just using construction lines here, not too heavy. And we'll just bring them all the way down to the centre line. They won't go as far as that in the end, but it's just for construction work. Likewise, we want to do the same here. So we're wanting to bring these points across. That line's already there. This point and this point. Okay. So we have a range of construction lines that we're wanting to work with. Now, firstly, this plan is incomplete because as we look down on top of it, in the direction of my pencil, you can see that this sloped surface here will result in the pipe starting here and finishing here. So, let's project up those points. And that point there will cut through and it will feature there. This point here will be here. Okay. And simply put, the rest of these points we need to project up and find the correct line that they're sat on. So, let's bring that up. So this point here will feature there and there. This point here will feature there and there. And you can see the curvature there. here, it's a symmetric shape, so it's going to feature here and here. And this one here is going to feature there and there. Meaning that we have these 12 points here, and we can simply sketch these in freehand. And if you need to go over that again, feel free to do so. Just to darken that in. So that's the first part of our drawing, and we've completed this part of the plan. Now at this point, you notice there that I used 12 segments. It's wise to use the numbering from a clock face at this point. Starting at 12 in the same position as the clock. And knowing that each of these points, therefore, refers to a point on this. Okay, so for example, that's 12 o'clock, that's 6 o'clock, that's 3 o'clock, and that's 9 o'clock, and so on and so forth. Okay, when we know that those numbers apply on the plan view, then we can transfer them to the elevation. So for example, this point here is going to be number 9. This point here is going to be number 8, 7, 6, 5, 4, and 3. Okay, and we will use these points now to construct the next part of this drawing. Okay, so 12, 6, 3, and 9. Okay, and the rest of the numbers will fall into line as you would expect. Okay, so as they come across now, and where they cut through this larger cylinder, we're going to just make some reference points here, and we will then project these straight down. So in other words, you can see here that this is coming down. Number 6, which is here, is visible to us on this side. So there's number 6 on that line there. So we're going to make a mark there. If you like, number 12 here is over the other side, so we can't see it, but we can see number 6. So 6 features here. Number 7, this is number 7 here. And it also applies, that same point applies to number 5. Because there's 5 there, it comes across to the same point, so therefore we're going to apply that to number 5 too. This point here is number 8 and number 4, so we can bring that down to here and to here. So we have these points now on here, and again, simply if we freehand this in, we end up with a curve that looks like that. Okay, so that's that elevation now completed. The next part of this drawing is to draw a symmetrical half surface development of the small cylinder. So this part, in other words. And it's only looking for a half because, as the name suggests, it's symmetric, so we don't need to draw the full 2 sides of it. Now, this pipe is angled at 30 degrees in this direction, which means that coming down the way, to be right angled, we need to project our lines down at 60 degrees. So this is this flat surface, and we're going to work from this flat surface to draw this surface development. Okay, so in terms of stepping off the correct sizes, what we need to do is refer back to this cylinder, or indeed this one, it doesn't really matter, but I'll use this one here. And we're looking to just measure the distance between, in effect, one side of the cylinder. If you imagine a cylinder being, in the case of drawing this, it's a 12-sided shape. Then this is the length of one side. And I'm simply going to step that off 6 times, because obviously if it's a 12-sided shape and it's only asking for a half of the object, then that's 6 times we're stepping off. Okay, so we have 1, 2, 3, 4, 5, 6. Okay, now we're going to use the same numbering system that we have deployed here. So 9, 8, 7, 6, 5, 4, 3. So we'll start off with 9, 8, 7, 6, 5, 4, 3. Those lines I want to project down at 30 degrees, like so. Again, just using construction lines, nothing too heavy. And at this point, it is simply then a case of projecting down at 60 degrees the actual heights of each line. So there's number 9. So if I take the height of that and I project it down accurately at 60 degrees, make a dot on each line. This is the height of number 8, there. That is the height of number 7 as it cuts through that construction line there, so that's number 7. That is the height of number 6 there. This is the height of number 5. This is the height of number 4. And that is the height of number 3. Then you can see here it gives me these points, and again at this point it's just a case of freehanding the actual curve. And that is our symmetric half of that surface development for the small cylinder. Okay, so that's what that looks like. The last part of the drawing is to complete a development of the large cylinder. So that's this part here, and we have to draw over here. Notice that this part of the drawing here is directly in line with this part of the cylinder. So in other words, we can use the information that we've got here to help us. So we can draw some light construction lines there to help us with this. Now this time round it's asking for a development. It's implying a full development, so we're going to draw a full development of this. Now, if you've ever created a surface development for a full cylinder before, you would know that it's in the shape of a rectangle once we draw it out flat. If you've never done that, then imagine the label from a can of beans or a can of soup or something like that. If you've ever peeled it off and rolled it out flat, it looks like a rectangle. So in effect, that's what we're going to have here for the most part, except we're going to have an area in that rectangle where we're going to have a cutout that features or that follows the profile of this curve. But as it's rolled out flat, you'll see it in its actual true shape. Okay, but first of all, we need to find out the actual size of our cylinder. How big does it need to be? Well, again, we're going to use this circle here, and we're going to split it up into 30-degree segments, just so that we can get some sizes to to work from. Now it does generate a lot of lines in your drawing, so that's why you need to keep them light. If you go in too dark, you're at risk of confusing yourself. Okay, really at this point, all we're really looking for is, well, two things. We need to know the size of each side, if you like. So on this occasion, it's going to be slightly bigger than the size before, so we're going to take that size and we'll step it off 12 times here. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12 times we've stepped it off. So the actual size of the rectangle that we're wanting to work with is going to be this size here. That's an accurate measure of the full size of the rectangle without the cutouts. At that point, I just want to draw some light construction lines at each point that we marked out. And like before, we're going to use a numbering system. Now, the most obvious numbering system is if you split a circle into the segments of a clock, so starting at 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10, 11, back to 12. Okay, so I'm going to start my surface development at number 3. Okay, so I'm going to start here at number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3. It always comes back to itself. Okay. Now, at that point, we can then see what things begin to look like. So, we know that from point 5 round to point 1, this cylindrical shape is unaffected. It is a solid cylindrical shape, and so the surface development will just be rectangular. It's what's going on between point 5 and point 1 that is where this features. Okay, so what we really need to know then is where do the points occur on this surface development in order for us to draw this correctly. And what we can do at that point is we can take points that we actually know. So we actually know where points 2, where points 3, and where points 4 feature. Okay, 2 is there, 3 is there, and 4 is there. So we can bring those down onto this drawing, which will give us the heights that we can then project across onto the same numbers. So there is point 2, so we can bring that down to there, where it cuts through that, and there as well. Okay. And points 3, well, 3 is there and there. So those points are already obvious to us. So we can bring them down as well. So this one here, this one, this one, and this one. But you will notice that it doesn't quite hit number 1 or number 5. So what we need to do, therefore, is we need to measure the distance from point 4 to that point there. And once we do that, That's measuring from point 4 to there. So you can see that that's a size going from 4 to 5, starting at 4, moving along to 5. So I can mark that off as a distance here and make a dot. You can see as well that it will be the same going from 1 to 2. So in other words, from 2 to 1. So moving from number 2 here, round towards number 1, it's going to be the exact same size as it would be going from 4 to 5. So from 2 to 1, we're going to mark that off and make a dot there. Now at that point, I want to just bring another working line up like so. What do we know? We know that at that point, that feature's there. So this line, this new line that we've put in between 4 and 5, and in between 1 and 2, is going to feature that at that height. So we can then project that across onto that new line that we've created. That one, sorry. We also know that the top and the bottom of number 3 feature here. So we can start here with number 3, project it across to the same number 3 on the other side, and the bottom of it is there. So we're going to have a half curve that comes around here, and we're going to have another half curve that comes around here. We just need to find the height points now on this line in between. And that is simply a case of, because we brought down number 2 and 4 previously, and that featured here and here. So in other words, bring these across to there, transfer it over to the other side as well, and then here as well. So you can see where this curve is going to feature. And at that point, it's just a case of freehand sketching the curve into position. And then you can finish off by rubbing out any lines that wouldn't be needed. Now, that is that drawing complete. If I was to cut both of these surface developments out and roll them, they would produce these sorts of shapes here. Okay, so that's what we're looking at really. These things joined together to produce these cut cylinders. Okay, so that's surface developments of two cylinders that are joined together in an intersection.